Okay, should we start, Miguel?
Yeah, whenever you want.
Okay, so today we have Miguel Almunia. Miguel is a professor at CUNEF and PhD from Berkeley. And today he's going to tell us about what are the drivers of export flows, mostly in Spain and possibly elsewhere. So it's good to have you with us. Miguel, you can start whenever you want.
Thank you, Carmelo and Luis, for the invitation, and thank you everyone for attending, despite the competition from the other session. So I'm happy to be giving my first presentation at Complutense, and sad that it's not in person. But these Wednesdays we usually have a seminar, and I have teaching and everything. So I hope I'll be able to come when we're all vaccinated and we have better teaching schedules. But I hope you will find this paper interesting, and I hope you will feel comfortable asking questions at any point, as we would do in an in-person seminar. So the paper is joined with Paul Antras, David Lopez Rodriguez, and Eduardo Morales. So as you know, probably Paul and Eduardo are in the US, in Princeton and Harvard, and David is one long-term co-author of mine who is at the Bank of Spain. Oops. So, okay, so what happened in the Great Recession in Spain? Everyone in this audience knows that we were heavily affected more than other countries, and the recession was quite long. So in this graph, in the red line, you can see the evolution of GDP normalized to 100 at the peak in 2008. You can see that over the 5 years after 2008, we lost almost 9% of GDP. But if you look at the external and internal components of demand, there's different behavior. So domestic or internal demand peaked also in 2008, and then it declined even more than GDP. But exports, and here we only have exports of goods. I've extracted services from here because we don't have data on service exports. I'll explain that in detail. Exports plunged in 2009 when there was a global trade collapse, but then saw an amazing, spectacular acceleration, growing about more than 30% between 2009 and 2013. So recovering the trend of growth of exports that we had before, and even going further. Okay, so this is part of the story we're trying to understand in this paper. Why did Spain have such a big export boom in the middle of the worst recession in decades? And you can see that this is, even though this was not a Spain-only phenomenon, the recession, you can see that compared to other European countries, these trends are very marked. So again, in red, here I have the share of GDP, nominal GDP, of Spain as part of the Euro 12, so the 12 original countries of the Euro. And you can see that in 2009, our GDP was almost 12% of that set of countries. And that share declined until 2013, all the way to 10.5. So this is the right scale. So we did much worse than our peers and our neighbors. But in terms of exports, we had a share of the exports that go outside of this set of countries, so outside of the Euro 12. In those exports, we did much better than the others. So our share of those exports that go outside of the EU 12 went from about 5.5% to almost 6.5%. Okay, so even compared to the peers, we did much better. In the paper, we explained that this pattern was more or less the same in other Southern European countries like Italy, a bit less Greece, but Portugal, even Ireland, even France. And it was a bit different for countries like Germany, who gained weight in terms of GDP and whose external sector didn't necessarily improve. So there's two leading explanations to this Spanish export miracle of the last decade. The first one is internal devaluation. So this was the favorite kind of policy recommendation from credit lenders to Spain, IMF, and some parts of the European institutions, that we should lower labor costs to regain competitiveness that we had lost during the boom. If we look at the data and we focus on manufacturing unit labor costs, we see that labor costs did go down by 3.8% relative to those of euro area countries. So to some extent, we had some lowering of labor costs. This could explain this boom. But there's this other explanation that is called vent for surplus, which is a bit more, in a way, it's very intuitive. It basically says domestic demand collapsed and firms had a lot of excess capacity because they had been building capacity during the boom. So what they did is adjust their production process to sell stuff to export in foreign markets, where the demand hadn't collapsed as much as in Spain. And we're going to try to convince you in the paper that what firms are doing in particular is adjusting the production process so that they reduce the use of variable inputs, think materials, think temporary employees.
Miguel?
Yes.
I'm not sure if everyone is hearing you well, because your network is
it
like losing strength. So your voice is cut here. I don't know if anyone else can tell us anything.
Yeah, I have the same problem.
Yeah. So you are.
It's cutting. The voice is cutting.
Okay. Miguel, I think you're losing a bit of network there.
Yeah, unfortunately, I'm not going to be able to cut, to connect by cable. So
maybe you can cut one of the
explanation of the figure is the next slide.
Here, the internal devaluation?
After internal devaluation, just when you began to explain the second explanation.
Okay. So
maybe Miguel doesn't have enough capacity for the two Wi-Fi lines, something.
No, but I'm not connected on two computers. It's just one computer connected to another screen. How can you hear me? Okay, now you can just stop.
Maybe you can deactivate the camera.
I could deactivate the camera. So
that's a pity. You can try now.
Is that better?
No, apparently it is not.
I'm still cutting off. Let me try one thing that probably.
I don't know. Is he using Wi-Fi or cable?
Yeah, I'm using Wi-Fi. Yeah. Let me deactivate everything else that could be.
I cannot hear anything from Miguel.
Sí, es su wifi,
It's CUNEF's Wi-Fi.
You also may disconnect yourself and connect it back again.
Well, the typical trick.
Yes.
I could try. Someone suggested connecting through my phone, and that has worked in the past. So let me try that.
¿Tú crees que ha desconectado una de las sesiones? Porque a lo mejor lo que...
No tiene una, es que está compartiendo al compartir le aparecen dos sesiones.
¿Tiene estas dos sesiones?
Claro, porque dice que está viéndonos a nosotros y la presentación.
No pasa nada, pues
Okay.
En una pantalla de...
¿Sí?
Sí, claro. En una pantalla pones la ventana de la presentación y otra...
Bueno, tienes que tenerlo preparado para eso.
How about now?
Now a little better. Try again.
Better?
Yeah.
Okay. So should I start again with the two explanations of the export miracle?
Yes. More the second one.
Okay.
And at some point, maybe try to switch on your camera again.
Yeah.
Good.
Okay. Let's try with it. Now I'm on the phone connection, and hopefully.
Yeah, you have to share. You have to share again.
Okay. Yes. Window. Now?
Now everything okay. Go
Perfect.
ahead. Perfect. Yeah.
So sorry about that. So I've explained internal devaluation. You all heard about this in the past. So vent for surplus. What's the idea here? The idea is that you have this massive negative domestic demand shock, and firms have capacity to produce a lot, but there's not enough domestic demand. So the very simple idea is that they're gonna move to serve the foreign markets. Okay, so more specifically, what we think they are doing is they are adjusting their production process by reducing variable inputs. Think materials, think temporary employees, which are a key variable input for Spanish companies, which lowers their short-run marginal cost. That makes them more competitive abroad, and then they can increase their exports to foreign markets. So this vent for surplus mechanism implies a negative causal relationship. So this is not just a correlation, this should be causal between domestic demand and exports. And this operates through the firm's domestic sales. So the idea, basically the paper can be summarized in these few arrows. There's a drop in domestic demand, which causes a drop in domestic sales of firms. And if we hold the prices of production factors and productivity, this is going to increase exports by firms affected by this shock. So this vent for surplus mechanism is a firm level partial equilibrium relationship. It's not general equilibrium. There might be other effects that affect factor prices and productivity, but in terms of partial equilibrium, we should observe this. Okay, now you can hear me, right?
Yes, we can.
Perfect.
Yes, yes.
Okay, so
I have a question actually, Miguel.
Sure.
So you were saying that this effect, this export boom during the crisis, is found in other southern countries in the EU zone, right?
Portugal, Italy, to some extent, Greece.
So I was wondering on another explanation, more IO based in terms of, you know, this kind of low quality, high quality specialization between North and South, something like that. Does this make any sense to you?
So why would the demand for low quality? So you're saying that southern countries would have specialized in low quality, low cost
varieties? Yeah. So then the recession arrives, and it's the share of low quality varieties is bigger now. Something related with that?
It sounds plausible. Definitely, it's not something we can measure in the paper with the data we have. So I'll explain the strengths and limitations of the data we have. And eventually, I will say briefly, what we're going to find in the data and then the quantification is that the contribution of this new mechanism is going to be about half of the export boom. So basically, the other half will have to be explained by other factors, which could include the story you're telling and many others. So there could be other stories. We're definitely not claiming that there's nothing else happening. What we're going to claim is that this vent for surplus is inconsistent with existing models that explain trade at the firm level, and we're going to provide evidence in favor of it rather than claiming that the other stories didn't work. But maybe we can go back to alternative stories when I'm a bit further explaining this particular one. Okay. So in terms of the contribution, we're going to test for the presence of this vent for surplus mechanism, and we're going to quantify it. Okay, so the main identification strategy, and it has many pieces, so I will spend many slides explaining this in more detail, but the main idea is going to be, we have data for 13 years between 2000 and 2013. Because of the way we construct the variables, we can only start the analysis in 2002. So we're going to divide the sample into two periods. The boom period, 2002-2008, where there's high growth in the economy and strong domestic demand, and the bust period or recession period, where domestic demand collapses and we see the boom in exports, okay? And to have identification, we're going to exploit differential geographic impact of the Great Recession in different parts of Spain. So we know that all of Spain was affected, but some regions were more affected than others. We're going to exploit that. So how exactly? We have data at the municipality level on the consumption per capita of a durable item, vehicles, and this is going to be our proxy for the demand at the municipality level. Okay, so we have this data on the demand for vehicles, municipality level, and this tells us the demand that a firm in that municipality is facing. But we use this together with information on municipality to municipality trade flows of manufacturing goods to capture the extents to which what a firm located in Madrid, they're going to be affected not only by the demand in Madrid, but the demand in other places, in Zaragoza, in Valencia, in Barcelona, to some extent. So we're going to use this information on trade flows of manufacturing goods across all municipalities in Spain to create a gravity-based weighting of these demand shocks. Okay, so we're going to use these two pieces of information to construct this instrument for domestic sales of Spanish firms, so the Spain-wide sales. And that's going to be the way we get identified, so then we can see the effect of changes in domestic sales on exports, instrumenting domestic sales by the demand for vehicles. Okay, so that's the main idea of how we identify, and most of the talk is going to be a bit about how we construct the instrument, the results we get with that instrument, and a lot of robustness checks of this particular instrument to check that it's capturing the demand shock and not the supply shock. A lot of this paper is very simple. There's demand shocks and supply shocks, and the only ones we want to quantify and estimate is the demand shocks. We would like to keep the supply fixed, so I will explain how we are doing that. And to control for the supply shocks, we're going to have information on what's happening to wages in firms, to productivity, and to the cost of finance. So what's the main result? At the intensive margin, we find that the relationship between demand-driven changes in domestic shocks and exports at the firm level is negative. So when there's a demand shock that makes domestic demand lower, exports are going to increase, and this elasticity is minus 1.6. So a 1% drop in domestic demand increases exports by 1.6%. But keep in mind that this doesn't mean that firms are going to overcompensate. Firms in our sample have about a 20% export share to begin with. So if you have a 20% export share and you lose 100 euros in domestic sales, you're going to recover about 40 euros. So the minus 1.6 is the elasticity. So this is the percent change in exports, minus 1.6, the percent change in domestic sales. If you plug the numbers of the 100 euros here and the fact that we're assuming a 20% export share, so exports are 1/4 of domestic sales, you will get that the firm recovers 40 by increasing exports. So firms are still worse off, but they are the shock is a bit less negative because they've managed to sell abroad. I see a raised hand here.
Yes, Miguel, I'm Luis. And my question is, if this mechanism is so good, why firms didn't use it before? So there must be a reason why this mechanism is used only after the shock and not before the shock, isn't it?
So before the shock, domestic demand is so strong that firms are selling a lot to the domestic market, right? So
it doesn't matter. If this is a good movement, you should do it because, you maximize profits, right?
What you're suggesting is true in a model with constant marginal cost, where the decision of where a firm sells in terms of the two markets, the domestic and foreign markets, are separable. So if I have the opportunity to sell, then I'm going to increase my sales in both markets. What we're going to argue towards the end is that actually a model that explains this better is a model with increasing marginal costs, in which case
even if marginal costs are increasing, if they are not very, very increasing, you have to check that this kind of movement was not profitable before the shock.
So,
and you have to check that with your elasticities and everything before the shock. This was not profitable, right?
Right. So in the quantification,
unless you have a completely rigid demand in which you say, look, and we have a very rigid, very rigid marginal cost. So you have a capacity constraint. And then, yes, this kind of movement doesn't make much sense, you know. But my idea is that firms always have some kind of excess capacity, you know.
Right.
Anyway.
So our point is that with this shock of the Great Recession, the excess capacity that opens is more than in other periods of time, and therefore that's what allows firms to really cut down on short-term variable inputs, and that allows them to lower their marginal cost substantially in this particular period. If our mechanism was symmetric, so negative local demand shock, I export more. With a positive local demand shock, I should export less. That we're not going to be able to study because we cannot analyze this mechanism at a higher frequency than what we do it. And this is going to be an important issue that I will explain. And then for the quantification, you were referring to quantifying the importance of the elasticity. That's what we do towards the end, to quantify the potential power of this particular mechanism versus others. Okay, so I will try to give at least a partial answer to that later. So those are the intensive margin results. The extensive margin, where you could in principle think that this mechanism should also work, we don't find evidence, definitely not robust evidence, that the mechanism is working that way. So it doesn't seem that firms are starting to export thanks to this mechanism. It's mostly firms that are already exporting, they increase their export share in response to a negative local demand shock. And in the quantification, just to summarize, what we're going to find is that about half of the export boom in this period of recession is explained by the event for surplus mechanism. And of course, there will be the other half, which is explained by many other factors that we don't incorporate here, like demand, other factors that affect prices. It could be the quality of Spanish goods, many other factors. Okay, so in terms of contribution, this idea of event for surplus actually comes back all the way to Adam Smith. And interestingly, when we started reading about this hypothesis and everything, so Smith has this in the Wealth of Nations, this idea that when local demand is low, firms will export the surplus to other markets. But many other authors and the standard international trade, this is incompatible with comparative advantage and a lot of models. So there's been very little literature following up on this. And in many fields, we consider Adam Smith kind of the trailblazer, but in trade economists don't have many good things to say about Adam Smith. So we're going to apply this intuition and show that in settings like the Great Recession in Spain, it actually seems to be working. This idea of the interdependence between markets, export markets and domestic markets across firms is not completely new of this paper. There's a few papers in recent years that have kind of looked at this kind of interdependence in Belgium, in Blanchard and Portugal do it for Portugal, and a bunch of other papers. There's this paper looking at French data, which has kind of results that are a bit contrary to what we find. And then extensive margin complementarities in earlier research by Paul and Eduardo. So here our contribution is that we're going to study the impact on exports of this large domestic demand shock, which is not present in many of the other papers. And we're going to use this IV strategy that is novel as well to have a credible instrument for domestic sales. Okay, so the rest of the talk, let me see how much time I will have. I'm going to introduce a baseline model, which is the standard Melitz type model with constant marginal cost to see what are the implications. And this is the model that we're going to try to prove wrong. Okay, so I will try to go relatively quickly because it's a kind of standard model. Then I'll tell you what data we have, explain more carefully the identification, show some results on robustness, and then towards the end, show what would be the model we think is more correct with the increasing marginal costs, and then the quantification. Okay, so it's an ambitious plan, and I might have to cut a little bit here and there. Okay, so the baseline model. Here, there's going to be a bit of an overload of notation, but I'm going to try to convey the simple ideas. So we have that firms are indexed by I, sectors by S, and they have a demand in each of the markets, domestic market and export market. Okay, you could make this model with many markets, but we're going to say that there's only 2. Okay, and you have the price set by the firm in market J, so domestic or foreign, and you have the sector level price. And you're going to have, this is expenditure, so this would be the market size. This is the size of the demand in that sector in the domestic market or foreign market. And these size are going to be the demand shifters, some random factors that affect demand. And sigma is the elasticity of substitution, which is going to be bigger than 1. Estimates of this parameter are around 5 in the literature. So the key assumption here is that the marginal cost is constant. The marginal cost of firm I is always going to be some trade cost at the sector level, some cost of factors that is firm specific, and some productivity, which is dividing obviously, which is also firm specific. Okay, and if a firm wants to enter a new market, it has to pay fixed cost Fij. So the firm is going to choose optimally the quantity they offer in each market, and they're going to take prices as given. This is always going to be the case in all both models that we firms are price takers. Okay, so here, because the marginal production costs are constant and the fixed cost of going to each market is fixed, the problem is separable. So if a firm is doing well, it should do well both in the domestic and the foreign market. If it does poorly, it should do poorly in both. Okay, so then what's the revenue from sales in each of the market? Here again, we have J, so you have to imagine this same equation written for both the domestic market and the foreign market. And these hats are log changes, because everything in my regressions is going to be log changes. So all these hats mean this is the change in the sales in the domestic market or the foreign market. So that change is going to be a function of the changes in demand shifters in the market, changes in my productivity, changes in my factor costs, changes in my trade cost, in my prices, and in the size of the market. Okay? So if you notice, if you think of this as my sales in the domestic market, it doesn't depend on the foreign market, and the same way for exports. The change in my exports is not affected in any way by the change in my domestic sales. So if we did a regression where we include here on the right-hand side the change in domestic sales to explain change in domestic exports, in exports, we should find a coefficient of 0 correlation. So under this model, the 2 decisions are separable. There's no correlation between domestic sales and exports. Now, let's think if we try to estimate this beta, what would be the properties of the OLS and the IB estimators? And here we have to be aware that we're going to have measures of productivity. Remember this letter, this is representing productivity. When I put a star, that means what we can observe. So we're going to measure TFP in our data, but we know that's an imperfect measure. So the imperfect measure that we have is the one with the star, and this is the true value of productivity. And the same with input costs. For input cost, I'm going to have changes in the wages in the firm. There's the observable part and the true part. So the true is also going to have a sector component, which we're going to account in the empirical analysis with sector fixed effects. And then it has some residual value. And this one, we just don't know. And we're not going to be able to incorporate in our data. So then I can write again the change in the revenue from sales in each of the markets. And now the error term is going to include this residual demand term, the part of productivity we don't observe, and the part of input costs that we don't observe. And the fact that this is in the error term is going to matter. Those of you who are in applied macro, always the devil is in the error, in the details of the error term. Okay, so if we did a regression and OLS, where we just estimate a regression of the change in exports for firms on the change in domestic sales, the probability limit of that OLS estimator would be the covariance between these two things divided by the variance of the domestic sale. And this is going to have all these residual terms of the error terms. And notice that here we have the productivity error term and the wage error term are going to be on both sides. So we're going to have a positive correlation on the numerator. The denominator, of course, it's a variance, so it's going to be positive. So if we do OLS, we're going to get a positive coefficient, as long as the first productivity and production factors are not perfectly measured, which is the case, and as long as we have market or firm-specific residual demand, so these UIX, UID, these are the residual demands in the domestic market, in the foreign market. If those are correlated, again, we're going to have a positive correlation. So OLS is biased upward. If we just run this OLS, we can have two things. We might have that beta is positive, and this is not very informative because we know this is biased upward. If it's positive, we know the true value is lower than that. We don't know if it's 0, positive, or negative. If we get that beta is negative, then this is informative because we know we're getting something negative that was upward biased. So that means that the true beta is even more negative than what we find. Now, if we have an instrument, a valid instrument that I'm going to call set I, so something that we can define at the firm level, and with instruments, as usual, we have to have the two conditions for the instrument to be useful. First, it has to be correlated with the firm's domestic demand, right? So we need an instrument for domestic sales, something that correlates with the domestic demand that a firm faces. And I'm writing here, after partialing out sector fixed effects and determinants of marginal cost like productivity and wages. Okay, so this would be the strength of the instrument. The first stage, I'm going to show you that our instrument fulfills this condition. And the second one is the exclusion restriction. The instrument has to be mean independent of the export demand, the firm's idiosyncratic export demand. Okay, so we need something that is not correlated with the demand of the firm or the residual determinant of marginal cost, productivity and wages. Okay, so this one I cannot show you directly. I have to convince you that our instrument is indeed not related to the demand for the exports of the firm. Okay, so if the instrument satisfies this condition, then if we don't get beta IB equals 0, then it means that the model is not correct, right? Because the model tells us that beta should be 0. Okay, so this is the thing we can test. Other questions up there? I hope I've conveyed the intuition. I know there's a lot of notation, but from here onwards, I think everything is quite straightforward. So data. We have 4 sources of data for manufacturing firms in this period in Spain. The main one is Central de Balances, which is a data set that the Bank of Spain has that comes from the commercial registry, Registro Mercantil. So every firm has to publish their accounts and balance sheet every year. So we have sector, the location of the headquarters of the firm, total sales, labor expenditures, employees, etc., assets. Then for the export data, we have a foreign transaction registry of the Bank of Spain, where banks had to report every export and import transaction over a period of time that actually ends in 2013. And this is going to include all the transactions above a threshold. So all the transactions that are bigger than 12,000 euros until 2007, and then 50,000 starting 2008. So we're not going to observe every single one. We observe every transaction that has a decent size. Then the data on vehicles comes from the DGT. And then we have to do our gravity estimation. We have tax records of the firm level sales inside Spain for manufacturing firms. Okay, so this is going to tell us each firm in our sample, which is 8,000 firms, how much they sell to each municipality in Spain. We have this only for 1 year, 2006, but this is going to tell us how exposed they are to shocks in different municipalities. And we have also not only the firm level, but the municipality to municipality flows in terms of manufacturing sales. So just to plot our data a little bit at the province level, this is the log change in domestic sales for the average province, and this is in standard deviation. So more darker red means that domestic sales increased more, or in most cases declined less, and the lighter colors are where the domestic sales decline more. So we can see that in the south and in the east, the recession was tougher, and in some areas of the center and the north, the recession was a bit less dramatic. And this is the average change, log change in the stock of vehicles, which is the instrument. You can see that it was above average in a lot of provinces in the center, except Madrid, kind of below average in most of the Mediterranean coast. So this is just to show that we have geographic variation in these variables. And this is the aggregate, the stock of vehicles per capita. So this is number of vehicles per person. The national average, you can see that in the boom period, it was increasing. And after we start the recession period, it basically became flat. Okay, so this is one of the pieces of evidence, we have more in the paper, that justifies that we have two very different periods, the boom and the bust. And even this is at zip code level, you can see that we also have variation, but let me skip this because it's a bit less relevant. Okay, so if we do the OLS, we said that if we just regress the change in log exports at the firm level on the change in log domestic sales, we're going to get a positive coefficient. Okay, we said that this is upward biased, so it doesn't mean much that this is positive. It doesn't tell us much. So then if I introduce, this is with 8,000 firms. Here I don't have firm level fixed effects because we only have two periods. So I'm just boom and bust, and I'm just taking the change from one period to the next on the change from one period to the next. If we include controls for TFP, the change in TFP and change in wages at the firm level, you can see that this already becomes negative. So the relationship between changes in domestic sales and changes in exports already become negative. And if I add also province fixed effects and municipality fixed effects, this coefficient is quite stable, around minus 0.27, 28. Okay, so A means significant at 1%. So what this regression tells us is that once we control for basic things like supply factors and sector fixed effects and province fixed effects, we already have a negative OLS coefficient. But our model tells us that this is still biased upward. So our model tells us that this might even be more negative than we are seeing here. And notice that the correlation, if you're worried that the way we calculate TFP is going to be very correlated with total sales of the firm, the correlation is there, is 0.5, but it's not perfect. Okay, so we have those OLS results. At the intensive margin, let me explain how we're going to get something that is identified. The identification approach is based on three steps. So changes in vehicles per capita in a municipality are a useful proxy for what's been the change in demand in that for manufacturing products in that locality. So notice that I'm looking at the change in the stock of vehicles per capita, not the new cars bought. Why did we choose the stock? Because in Spain, there was one of these Plan Renove where people were incentivized to renew their car. And then we would see artificially many new cars, which are basically cars that are being replaced. What we want to capture is whether there's really more cars per person than before. That's why we choose the change in the stock as opposed to looking at the new vehicles bought. Okay, so how exposed are firms to different shocks inside Spain? We're gonna do a gravity equation where we say, okay, if you're in Madrid, what happens in Toledo affects you more than what happens in a small town in Andalusia, because Toledo is closer. But what happens in Barcelona, because Barcelona has a lot of population and a lot of links to Madrid, probably matters to you as well. So in the gravity, we're gonna put population and distance. And we're gonna use this to construct a weighted average of the changes in stock of vehicles per capita to instrument in domestic sales. And of course, we need to assume that the changes in the instrument that affect, that predict domestic sales are uncorrelated with any other supply shocks or export demand that are affecting firms located in that same municipality as the firm we are studying. Okay, so the first 2 points, basically what we're saying is this instrument relevant? Does this predict domestic sales? That we can show with the first stage. The final one is the exclusion restriction. The first thing we're going to do is that we're going to take out all the manufacturing firms that produce cars. We're going to take them out of the analysis because obviously shocks to the car industry could be related to shocks to the car industry in other countries. Okay, so the goal, of course, is to capture this exposure of firms to changes in domestic demand. So we're going to start with this gravity equation at the municipal level. We have the log of sales of trade flows between municipality M and N are a function of the population of the destination. This is what I said. Barcelona is going to have more weight than a small town in Toledo. Distance, of course, more distance, less likelihood that there's going to be trade between two municipalities, and municipality of origin fixed effects and some error term. So the coefficients on distance and population are going to enter this weighted average. So our instrument is going to be a weighted average of the vehicles in each municipality, where the weight is population times the estimate of this row times the distance to the power of delta, where delta obviously is going to be negative. So the row is going to be positive, the more population, more flows, delta is going to be negative. Okay? And the original paper, the original draft of this paper, actually the instrument was based only on changes in vehicles in your own municipality. And then referees complained that firms would sell a lot in other municipalities, so they wouldn't find credible that changes in the amount of cars sold in Madrid is going to affect the sales of a firm in Madrid. So here we've gone in the second version to the opposite extreme, where now we exclude the municipality of origin from this weighted average. So for a firm in Madrid, what's going to matter is the weighted average of the shocks in every other town in Spain except Madrid. Because there could be, if we capture the sales in Madrid, we could be capturing supply shocks. And remember that we want to capture only demand. So this is our gravity equation. We have multiple versions, but the one we're going to use more is column 1. So basically, log of bilateral trade flows between municipalities. The elasticity with respect to population of destination is 0.49. With respect to distance, minus 0.43. Okay? So this is what's going to allow us to construct this weighted average of the demand shocks.
Miguel, had you considered other variable as GDP, measure of GDP per capita, or the age of the cars in each municipality? Because in the gravity equation, you used to consider some measure of rent, and you only consider population and distance. You don't have information about some measure of GDP or by municipality, or
you mean for this gravity estimation, or for instead of vehicles as the main instrument?
No, for this gravity estimation. Because you only consider two of the typical determinants of this gravity equation. You know, I don't know why you are doing. I understand.
Population by municipality, but we don't have GDP by municipality, right?
Yeah, even the mean age of the car stock, you know, because the age of the car stock, I don't know. But I don't know how if you include more variables here, you know, because you are considering only the two typicals, population and distance.
Right. Yeah, because these are just to build the weights of how relevant the shocks of the changes in vehicle demand in different municipalities. Yeah. We're just trying to get. I mean, we could add more variables here as controls.
Yeah.
I think.
Probably it doesn't affect, you know, because the gravity equation works very well, you know, but even the transport, I don't know. It is sensible the result if you consider another variable in this equation. I don't know.
We could think about that, but I think data availability might be a constraint. maybe the age of the car stock, the average age we can get, but other variables it's gonna be hard at the municipal level. No?
Yeah, because of course Edu is an expert in gravity equation, you know, but that you are only considered two. I don't know. Okay.
Right. Thanks for the suggestion. Okay, so we do a variety of these specifications. When we include dummies for to own municipality and own province, and you can see that there's definitely, as the literature on gravity equations has documented, a big home bias, right? So this 1.6, because this is in elasticities, if you put it in proportion, this means that firms are more likely to sell, 5 times more likely to sell to their own municipality than to any other municipality, controlling for population and distance. So definitely there's home bias, and this is comparable to other papers, and even at the province level you see this difference, although here it's much smaller. We include dummies for different distance intervals, and that shows here, I don't have all the coefficients, but you can see them in the paper, that the effect on distance is quite monotonous. And then in the last 2 columns, we have, instead of firm to municipality, municipality to municipality data, here it's firms to municipality. And here the coefficients vary a little bit, but we have a lot of robustness in the paper where we use these gravities as the ingredient to construct the instrument, and the main estimates are robust. What we haven't tried is what Lourdes is saying of adding other types of variables here in the equation. And here we show that there's some variation in the instrument, even within provinces. Once we do this weighted average of the shocks, you might think, oh, but then firms that are located very closely, they're going to have all the same value of the instrument because they are in the same place. You can see that even within province, you have a lot of variation in the instrument. Okay, so this table would be essentially the main regression table. So let me spend a bit of time on it. This is the two-stage least squares with the instrument, which is a gravity-weighted vehicles per capita. So the first 4 columns are the first stage. Okay, this is how the change in the stock of vehicles weighted by the gravity estimates affects domestic sales. So the raw correlation of these changes is positive, but when we control for supply factors, the change in productivity and the change in wages, these things have the expected signs, and the main coefficient actually increases when we add the sector fixed effect. So this is the one, column 4 is the one consistent with the model I showed you in the beginning. We get this 1.3, and the F statistic on this instrument would be 122. So this is well above standard thresholds for instrument strength. So then the second stage of all these regressions would be correlative, so 5 would correspond to 1, etc. This one is not very credible. This -10, this is too large an effect, and it most likely is because we're not controlling for TFP and wages. Once we control and we add the sector fixed effects, we get this -1.6. So this is the elasticity of exports with respect to changes in domestic sales. This is the headline result that I used in the introduction to kind of explain the main results we have. So if domestic sales of a firm go down by 1%, their exports will increase by 1.6%, controlling for changes in TFP and their wages of the firm. Okay, so this is the negative coefficient. This is very far from the 0, which would be predicted by a model with constant marginal cost, which is the standard model in the trade literature. So from here onwards, it's mostly, well, I'm going to show you the extensive margin, and then it's all robustness analysis. The magnitude of the result, like I said in the intro, this is not a more than complete substitution. If domestic demand falls by 100 euros, a firm that started with 15% of their exports being of their sales being exports will recover 28, but a firm with an export share of 1/3 would recover 80 euros through the increase in exports. Okay, so this is the effect is going to increase with how exposed the firm was to the export market. And notice that in this sample of firms, the median export share is 16%. Okay, so it's going to be somewhere between these two. And clearly, these estimates are incompatible with the standard model. The extensive margin, our hope, to be honest, when we started this paper was that we would find a strong extensive margin effect. Here we try to apply the same logic, the same instrument, same everything. We change the dependent variable to an export dummy. So whether you export it in the boom period and the bust period, the OLS is positive, showing that this also is biased, as we predicted in the beginning. The first stage is common to the two regressions, is positive, and the statistic is high. And if we do an export dummy, we get an elasticity of something like minus 0.58 at the extensive margin. So this would be consistent with the intensive margin elasticity. But then if because we are putting together many years, it's almost more reasonable to have a proportion of years exporting in each period as the dependent variable. So this is kind of a continuous dependent variable. When we do that, we get a positive coefficient and a positive elasticity. So basically what we conclude from this analysis, and we spent a lot of time early on trying to get this robustness, these estimates to be robust, is that they're not robust. We cannot claim that the effect at the extensive margin is negative or positive. We just cannot tell. And in any case, it's not only statistical significance, it's also that the coefficients are quite small. Okay, so this elasticity is always going to be smaller than the intensive margin, which is minus 1.6. Okay, so based on the evidence we have, we cannot say much about the extensive margin, but it looks like the effect is not as strong as on the intensive margin. Okay, are there any questions, comments at this stage? Because I'm going to move to robustness and probably do them.
Sorry, just one clarification. So in the main results, you use only exporters, right? Firms that were already exporting before the crisis.
Here, in this intensive margin, these are firms that export at least in one period in the boom and in one period in the bust. Because remember, I have annual data, but I'm lumping it together to a longer period. Here, I'm including more firms, because here I can include firms that didn't export in any of the periods. That's why here we can look at the extensive margin, because we have all the manufacturing firms for which we can define all the variables. So here we have like 60,000 firms. Here we have 8,000.
Okay. So you're basically conditioning on exporting in the main regression, let's say.
Indeed, yeah.
Okay.
We are.
Miguel, have you tried with other definition of the extensive margins? Because maybe there are some switch first that switch enter and exit, and maybe if you consider other definition.
We tried a few. We tried the number of years exporting, but then that was contaminated by the fact that firms are not in the sample all years. So we thought the proportion was a bit more neutral. We did spend quite a bit of time early on in this project, so years ago, on this, and it really wasn't. And also, remember I told you the first version of the paper, the instrument was very local. It was only, the instrument was the change in the stock of vehicles in your town, whereas now it's the weighted average of the change of vehicles in all other towns in Spain. With both instruments, we get the same, that the extensive margin is small coefficients and very, very unstable. So
yeah, but I think the result is in accordance with the papers of the Asier and yes, because at the end they say that the more important is the intensive margin, but they also obtain a little of extensive margin, I think so.
Yeah, we've talked to Juan de Lucio and Serminondo about this, and we cite their papers, and indeed our story in the end is consistent with what they, and this is something we learned after finding these results, because they saw a presentation, so they shared with us all their research on this, and we found that it was quite consistent. They claim that most of the growth in exports in recent years in Spain has been intensive margin, in that it's exporting firms that export more. They also define an extensive margin where firms move to other markets.
They increase the number. Yeah, they increase the number of markets that they use to sell.
Exactly. That's something we cannot capture because of the nature of the data we have. They have data from customs, which gives you. We have the data from Bank of Spain, which after 2008 doesn't give you
this information
on the different markets. But yeah, it's quite consistent with what they say, and we talk about this in the paper.
Okay.
Any other comments? Okay, so I'll go relatively quickly on the robustness so that I can tell you something about the quantification. We do a few things. The first one is to see what happens when we go to higher frequency instead of just boom bust, because the boom bust are 2 periods of 7 and 5 years. It's a bit coarse to do the analysis like that. We show that even if we go to higher frequency, the story still works, but not always. Then we do more robustness to taking out not only the firms, the manufacturing, the vehicle manufacturing industry, but also firms that could be affected to the manufacturing industry because they are in zip codes where you have lots of vehicle manufacturers or they are nearby, etc. We play with a number of alternative instruments. So early on in the paper, we tried different instruments related to the financial crisis, and we get very similar results actually with these instruments, although they are a bit less credible in terms of exogeneity, some of them. Then we control for other factors that could affect marginal costs, and we see that those don't have an effect. And we try different ways of measuring productivity, because this is one of the most controversial things to measure, because it's not obvious how you should measure TFP. So let me just quickly show you the higher frequency. And this is, we are revising this paper, and Luis was asking me, what are you guys working on? This is what we've been working on, this higher frequency, because this is what the editor and the referees have complained about. If we take our data and we take a moving average of all the variables, a 3-year moving average. So we take 2002, 3, and 4, we take an average. The next data point is 2003, 4, and 5. The next one is 4, 5, and 6, etc. And we do the same analysis, but with a lot more data. We get an elasticity of -0.21, and the instrument is still strong. If we do a 2-year moving average, so this is getting closer to annual data, it even increases a little bit, but our instrument is starting to become weak. This first stage is, the statistic is 7.7, so this would be kind of below standard thresholds. And the thing is, if we go to annual data and we include all our controls and we put municipality level, municipality-specific time trends, notice that in all of these regressions, because I have more than 2 periods, now I can control for firm fixed effects. When I go to the annual data, the instrument loses power. So this point estimate is positive, but the standard error is very big. You can see the statistic is 2.2. So obviously the two-stage least squares is not very meaningful at that point. Why most of the work we've done in the last few months is why does this regression with annual frequency deliver different results? And what we are concluding is that the shock affects different municipalities at different times. And on top of that, you have the lag of the effect on the economy goes a bit after the effect on vehicles. So vehicles are a lead indicator, and they tend to change. The demand for vehicles tend to affect about 6 to 12 months before a recession. So because the shock is at different points in time, and then there's a lag, then the moment you put year fixed effects, which is something we have in here, because some of the shock is in 2008, some of the shock is in 2009, the year fixed effects eat most of this variation, and then at the annual frequency, you don't get a powerful instrument, but you get it at all the other frequencies. So our point is, look, this process is slow, and it's not clear theoretically that it should work at the annual frequency. So the fact that we have annual data doesn't mean that it should also be present here, the result. But this is the result we have. So at the moment, we are showing all these regressions and telling the reader, we think this analysis should be done with the 2 periods, because you have 2 very different periods macroeconomically in Spain, and the story works in 2 periods, but it won't work if you go to the annual data. So that's the main issue between us and the publication. I don't know if you have comments or ideas about what else could be going on here.
Well, I have a comment. Can I speak?
Sure.
My comment is, do you have any control about how this decrease in prices affect in different markets? I mean, we export to a lot of countries, right? Like India, China, United States. Do you control for this, or you just take the rest of the world as one entity?
so far we do, and we do it because we don't have data on prices, on unique prices. So we show some evidence on aggregate evidence on prices to show that export prices from Spain did go down a little bit, but basically in our framework, because we cannot observe these different prices in different markets. Basically, what we're gonna do is assume that Spain is a small economy and firms are price taking. But yeah, this is something that if we had information on prices, we could do something a lot more sophisticated in that respect. And this again is something that we took a lot of criticism from people in this literature on trade, because other data sets do have info on prices, but we don't have micro level info. Any other?
Well, yes, just to clarify a little bit. So here you are using the instrument, let's say excluding the shock in the cars in the same municipality, right?
Yes. Mm-hmm.
No, I mean, because what we see here, the coefficients, let's say, go down, but they go down slowly, and the standard errors increase, but they increase very fast, right? When you kill some years.
When I go to higher frequency.
Yeah. Exactly. So,
yeah.
I don't know, maybe exploring why these standard errors increase so fast. Maybe you have some clues about why this is happening, right? Because can it be because there is more variation in the dependent variable, let's say in the domestic sales? Maybe there are some, I don't know, liars or something.
We don't think it's an issue of domestic sales, because when we do the OLS, where the instrument is not relevant, the OLS doesn't change dramatically when you change the frequency of the data. It is when we introduce the instrument that the first stage changes. So that one thing we have explored is that the peak, so for most municipalities, the vehicles per capita go up and they reach a peak and then they become flat or they go down in some cases. That peak is reached in 2007 in some municipalities, in 2008 in some, and even 2009 in others. Whereas the drop in domestic sales and the effects on exports are very well aligned. It happens for most firms in 2009.
Okay.
So we think that heterogeneity in the timing of one shock and the other shock that breaks the relationship in the annual data.
No, what I was saying is that this story about breaking the relationship would impact more maybe in the coefficient than in the standard errors, right? So I don't know if there is something about the collinearity between this car measure and the TFP, maybe, because the TFP also increases quite a lot the standard errors. Just wondering, my question was, if you use the original instrument you told us about on the same quality, this same pattern happens, yes?
Yeah.
Okay.
It's quite similar with both. So this issue has been there since the beginning of the paper.
Okay. Thank you.
Thank you. Oh, but these are very good comments. Thanks.
Okay. Miguel.
Yes.
I was thinking again in the previous comment by Lourdes on the specification of the gravity equation. Have you explored? I guess you haven't explored alternative specifications now that you use annual data.
We do use
this comment. What I meant is that maybe if you use this income information that you have through taxes, for instance. Maybe this timing that you are saying this lag in the
The thing is, with the gravity, all that we're using is the point estimates for the weights. So maybe I don't think changing the gravity specification, because we do robustness where we use all these 5 columns. In all the results I'm using column 1, all the main results, but then I'm going to use the other, and things don't change. It's more about really the data point of the changing vehicles in each municipality. So I guess with other instruments, like the ones we work on briefly later, a different instrument could potentially have fewer issues than the vehicles at the annual level. But actually, the other instruments I'm going to show you, they give us some robustness, but the assumptions on the exclusion, restriction, etc., are a bit less credible. So that's why we ended up choosing the vehicles as the main one. So yeah, I don't think it's the specification of the gravity equation that is going to matter.
Okay.
Probably we haven't explored as much as we could what's going on with the different timing in different municipalities, and maybe doing the annual data analysis with subset of data where the shock is timed similarly. We probably could try that as an additional step. Okay, let me move forward because otherwise I'll go over my time. So I'll just go quickly through all the other robustness. So excluding zip codes linked to the auto industry in a number of ways, because they are in zip codes where the employment share of the auto industry is high, the point estimate is the same. Notice that here we drop 900 firms. The point estimate is similar. Zip codes where there's at least one large vehicle maker, we drop many firms again, very similar point estimate. We can include the neighbors of the ones in panel A. So we drop another 1,000 firms, we get minus 1.6, and exclude other sectors which have input-output links to the vehicle industry because they could be affected. If something happens to the vehicle industry, could be affected. Here we drop 2,000 firms. The point estimate becomes, if anything, a bit larger in absolute value. So it doesn't seem like these supply shocks from the auto industry are relevant. Then the other instruments we try, we mainly construct this gravity-based instrument using the different specifications of the gravity equation. Okay, where we include the dummy for a municipality, the distance dummies, the firm to municipality flows instead of municipality to municipality. And we even construct the baseline instrument instead of the average of the log vehicles per capita, the average of the level of vehicles per capita, and we get similar results. So here, these are all the first stage coefficients with all these different specifications. So this is playing with the gravity equation, and here it's the same as the baseline, but in levels. And at the bottom, you have the second stage. The baseline is minus 1.6. This one is minus 1.3. The other one is minus 2.1, minus 1.7. But you see that everything is in the same ballpark. And more alternative instruments, here we use other instruments that have to do with the type of shock that the Great Recession had in Spain. So the share of buildable land, so terreno construible, even before the boom, before our period, which could have explained the boom, right? Towns where there's a lot of land that you can build, or the importance of tourism, which was also part of the boom, or the importance of the construction sector in employment. So instruments that we construct with these other variables, you can see here the point estimates. It's a bit less robust, but everything is somewhere between -1 and -1.5. Okay, with all these different instruments that have come from completely different places, and these are all, very different instruments that give you similar results. I'll say that some of these also had issues with the annual data, but it's been a while since we didn't check them. So it's something I probably after this presentation I will check what were the results in the annual data with these instruments, because all the robustness I'm doing them for the boom to bust changes. Then there could be confounding factors, right? It could be that our measures of wages and productivity don't fully capture supply. So let's look at the share of temporary workers, which are easier to fire in the recession. So there's going to be different effects on different firms. The share of manufacturing employment, either in the municipality or the province where you are, or the cost of finance. Okay, so we spend a lot of time in the paper explaining how we construct all these variables, etc. But from this table is that when you add all of these controls one by one, the point estimate on the main elasticity is very robust. Okay, so some of these are significant and they go in the direction you would expect. Mostly, some of them are not significant. Financial costs, in particular, of firms defined at the firm level or the municipal level, that don't seem to be explaining why we have this negative correlation between domestic sales and exports. And finally, TFP. Referees also complained that the TFP, the way we calculate TFP, they didn't like it because this and that. So we say, okay, our main TFP is based on sales. You have alternative ways of calculating TFP where the the production function is based on value added. We do that, and the IV estimate is 1.05. So it's a bit lower in absolute value, but still quite significant. So the measure of the way we measure TFP is not driving the results. Okay, so that's kind of the robustness of those results, and then we enter the last part, which I think is an important part, but I'm really out of time, so I'm just gonna give you the flavor. And this part we've rewritten in the revision. So if someone is really interested in this, I think we're doing a much better job at explaining this part in the new version of the paper. So the main idea is that now, forget about a lot of what's written here because it's going to be too much if you try to read. The main idea is we are now making the marginal cost of production increasing, and it's going to be driven by this parameter lambda. So now this is the marginal cost of production, and this, as the quantity produced for the domestic market and the foreign market increases, this is going to increase. But notice that if lambda was 0, basically this collapses to the original model I showed. Okay, so lambda equals 0 is constant marginal cost. Any lambda bigger than 0 is an increase in marginal cost. Okay, so then if we incorporate this marginal cost into our expression of the change in the sales to either of the markets, we see that total sales show up as one of the right-hand side variables. So now the total sales affect the behavior of sales either in the domestic market and the foreign market. And the intuition here is that how much I produce determines my marginal cost. And that's why this has to have a negative sign. If I produce more, my marginal cost goes up. So there's going to be this effect on my production. Okay, so now the regression we're running is the same as before, change in log exports on the change in total sales. Sorry, the first stage, instead of domestic sales, has total sales. So now it has exports plus domestic sales. Okay, so now our instrument is the same. We're still instrumenting with the change in the stock of vehicles, but now that is instrumenting for the total sales of the firm and not the domestic sales. And we have a long argument in the paper for why this is still identified, even though it's weird to regress the change in log exports on the change in total sales when exports is part of total sales. You'll have to trust me for today that this makes sense to run, because initially we thought it wouldn't make sense to run it, and we did the algebra to show it does. Long story short, the instrument of vehicles is still strong to predict the change in total sales. So we have a point estimate on the correlation of changes in exports given changes in total sales, and it's minus 2.37. And if you control for the changes in the stock of capital, which is something that also plays a part in the model, you get a similar coefficient. So this one, minus 2.37, is going to be the one we take to do the quantification. Let me skip this. So in the quantification, what are we trying to do? We're trying to say, okay, if there hadn't been such a big shock to demand, what would have been the change in exports in the Spanish economy? So we know exports increased for this sample of firms that we have, and it increased. We have the number here. I have to skip all of this because if I try, we know that exports increased by almost 12% between boom and bust in the firms in our sample, and we know that total sales decreased by 10%. So what we do in the counterfactual, and it's a long argument, is to simulate this gamma, which is the size of the shock to domestic demand. If it had been, we're hypothesized what would have happened if it had been bigger or smaller than the one we observed. So if we simulate a smaller shock, so a shock that would have reduced domestic sales reduced domestic sales by 9% and total sales by 6%, that shock would have increased, exports would have still increased by 5.8. Okay, so this is basically the counterfactual scenario that we simulate. So that counterfactual tells us that the event for surplus mechanism explains about half, So 579 out of 12 of the observed growth in exports. Okay, so it's a lot more subtle than what I just explained, but unfortunately, this is a very long paper and this is a short presentation. But one thing I haven't mentioned properly is that in doing this, we do something that Luis has pointed out already. We assume that Spain is a small economy, that prices would have evolved in the way they did because firms don't have market power, neither in the domestic economy, neither outside, and all the other marginal cost and foreign demand shifters, so everything that affects supply factors and foreign demand factors, all of that is fixed. The only thing we are changing the counterfactual is domestic demand. We're hypothesizing what would have happened if domestic demand hadn't fallen as much as it did. Okay, and basically the quantitative result is this one that we have. If domestic demand hadn't fallen as much, domestic sales would have fallen 9% instead of 16, total sales would have fallen 6 instead of 10, and exports would have increased 5 instead of 12. So our mechanism, which is just how much firms increase their exports when domestic demand goes down, explains about half of the boom. Okay, so apologies that I'm not giving you the details of this, which is, it's like an entire separate paper, I think, the whole quantification, but this is always left for last, and therefore we don't have plenty of time. So let me wrap up, and then I'll stay. I'm happy to stay around if people have comments and they don't want to run to lunch, but let me just wrap up and summarize a bit what we learned from the paper. So the main contribution is that we provide evidence, identified evidence, that there's some substitution between domestic and foreign markets in the short to medium term horizon at the firm level. And this is something that models with a constant marginal cost wouldn't be able to predict. And this is the model that trade economists are using to predict many other behaviors. So maybe in trade, people should be incorporating variable marginal costs in their models, and this could be founded on capacity constraints or a number of other assumptions that are going to give you have multiple ways of microfounding that marginal cost could be increasing at the firm level. And this quantification, we say that the event for surplus channel can explain about half of the export miracle of those 5 years for Spain. Of course, the other half, it could have been the internal devaluation I mentioned in the beginning. It could have been that wages were lower thanks to the labor reforms, although the labor reforms really started lowering wages in 2012 and the boom started in 2009-10. So it cannot explain everything, or it could be other factors like what Luis was suggesting. Maybe it's a quality price trade-off where Spanish exporters were better off. It could be other factors, but what we bring to the table is that these factors could explain at least half of the boom. And that's it from me. Like I said, I'm happy to take any more questions or comments.
Miguel, for the quantification, you use the second coefficient minus 2.5, no? It's possible to use...
For the quantification, we use the minus 2.37. So
it's possible to argue that you can use the first coefficient minus 1.6.
Not here, because once we extend the model...
Yes, you consider that you consider, yes, I understand that there are no constant marginal costs, and there are relationships between domestic and foreign production, no?
Right, through the cost, like the marginal cost now depends on how much you produce for each market, and that's why it's going to show up here.
Yeah. Because the coefficient is almost 1 point bigger than the other coefficient, and maybe for me the quantification is too much, the 50%, you know. Maybe it's for this coefficient, and you do all the robustness test in the first equation, but not in the second one. So we trust you that the is correct, you know, but this.
Fair point. We have yeah, we have an entire appendix where we rerun all the analysis that we run with domestic sales, where the explanatory variable is total sales. But it makes sense for this coefficient to be larger, because here you have both. So we're doing a regression on log exports. Before we were doing log exports on log domestic sales. Now we're doing log exports on domestic sales plus exports.
Yes, I know.
Mechanically, there's going to be some correlation there. So it kind of makes sense that this gets amplified because the component of domestic sales is. So here, in terms of robustness of this point estimate, which of course affects the counterfactual, if we use this number, this 2.59, where we are controlling for changes in the stock of capital, the counterfactual would be even bigger.
Even in the robustness, you consider the other cost variable independently. Maybe you can consider all together. When you do the robustness, you consider finances cost all.
Yes. Okay. You mean this table?
All together in the same equation. Yeah.
We would like to see one more column with all of them at the same time.
Yeah, because with the first of the central balance, you can have a specific cost for each firm, you know?
We do. Yeah, so some of these variables are at the firm level, some at the municipality level, but yeah, some of these things with the central de balances, we can define them at the firm level, definitely.
Yeah, because I don't know, maybe just to adjust the coefficient, I don't know. It's possible to do the same analysis considering that you have a constant marginal cost but difference, domestic and foreign cost, or you need that there are a relationship between both.
So how would you justify having different costs, marginal, because of course there's a fixed cost, let's say to export. How would you justify having a different marginal
because you
cost?
have some costs of south, just for example, when you consider you have to invest research about the foreign market, you have different pack, for example, you choose different presentation in different countries. Diego and me, we estimate marginal cost. We consider that they are different just because the preference in different countries, and we obtain marginal cost bigger outside than inside. But and there are a lot of literature that is justify different marginal costs inside and outside. You know, even if they are independent, we estimate all of them with a translog function because we consider different marginal costs, but they are not related. You know, I don't know.
Okay, you definitely know this literature better than I do because, as many of you in the audience know, my main field is public, not trade. But definitely, I'll discuss this with Eduardo and Paul, who are the experts. And
no, I don't know how
the literature allows. So if the literature does these marginal costs differently, definitely in our model that doesn't happen because it's the only difference of entering a market is the fixed cost. When you produce
equally. No, I can send you our paper, which is bisect another paper for Canadian and American economy, and they consider different marginal costs, but no, they are not just for this reason, you know, because you are selling different things, but it's okay. Just trying to explain that this coefficient is a little bit, and maybe can affect the quantification, you know. It's just,
yeah. I mean, it's one of the key ingredients. Everything else is kind of setting the assumptions we're making, but the main ingredient in the quantification is these assumptions and that point estimate of minus 2.37. But thanks. Yeah, it would be great if you can send me those papers so that we can discuss how that would change things.
Yeah. And the gravity equation, I agree with you that probably doesn't change anything, but maybe normally the referee asked me to include more variables, you know, in the last paper, not only population, I don't know. But
I actually think given the data we have, we should write a paper only on the gravity equation because it seems like we could contribute something on that. And right now it's just an excuse to build some weights in this paper, but we do more than we're doing on that front.
Okay. It's so nice. I have to leave, but thank you very much. I send you the papers. I look Thank you very much. Bye.
We all have to leave.
You all have to leave. You probably have to eat lunch.
It's a very nice paper.
Thank you.
Andres,
you have it?
are you still alive?
I think it's Luis before. No? He raised the hand before.
Luis Corchon.
Oh no, I'm sorry. I just forgot. I'm very sorry. I apologize.
An old one.
Okay. No, well, my question comment was very briefly is that you have the demand shock, and this demand shock may affect the TFP and the wages as well, right? So
We're
let's say,
assuming it doesn't.
sorry?
Because it's equilibrium, but in general equilibrium, I guess it could.
Yeah, exactly. So as you control by TFP, I mean, ideally, you would like to control by the TFP, that the change in TFP and wages that is not caused by the demand shock. And you would like not to control by the TFP change and wage change caused by the demand shock. Because if you do that, obviously you are, let's say, changing the causal effect, which is what the magnitude finally you are interested in estimating, right? You know what I
agree. Yeah.
Point. I mean, some way to try to disentangle both, or probably not.
We haven't found a way to make it tractable, opening up that kind of worms where everything can change. So yeah, we are mostly by assumption keeping all those other things fixed. With the argument that in the empirical analysis we are controlling at least for the observable part of these components. But yeah, it's
I mean, it's just something I was expected to be mentioned at some point, because, you know, now there is this issue of the bad controls, and you don't, when you want to estimate a causal effect, you don't want a post-treatment variable to be control for because you don't estimate the causal effect properly. And I don't know to what extent this is happening here, right? Should be probably to some extent, maybe not very large, but I don't know, something to have in mind, probably.
Yeah, no, I understand your point, but I'm afraid we're not going to have much we can do to fix it.
Okay, thank you.
So I think we are done. Thanks very much, Miguel, for your very nice presentation. There are many things. I hope we will keep talking about all this.
Definitely.
Ideas, yeah.
All right, thank you all, and I hope to meet many of you in person eventually.
Soon. Yeah, we hope so. So thanks, everyone.